Hello, this is a video on resolution of forces. So in this video, we are going to look at how we can resolve system of forces. We have more than one forces acting concurrently on an object into the resultant, into a single force, which can represent all the forces acting together. Now, before we can dive into system of forces, let's look at how to resolve a single force in the Cartesian coordinate, in the Cartesian plane. So let's say you have, this is what we'll be using. Remember the Cartesian plane, you have, this is the positive y direction, this is the negative, this is the positive x direction, sorry, this is the negative y, this is the negative x. So this is what we'll be using to resolve the forces. So if you have, let's say we have the Cartesian coordinate system, and you have a force F that is inclined at an angle theta to the horizontal. So this is y, this is x axis, y axis. Okay. Now this force has two components. It has a component along y, so if I call that component Fy, and it has another component along x. They call it Fx. So what do I mean by component along x? So the contribution of this force, if you remember resultant, if you have two forces acting like that, the resultant will go like that. So it looks like this force looks like the resultant, but this resultant has one force acting vertically and another force acting horizontally. So I'm trying to look at a way of getting that force back if I know this force and the angle, the direction of the force. So how do I do that? So to obtain the magnitude of this resultant, so if the component along y is Fy and the component along x is Fx, if I complete this triangle, so this will be Fy and this is Fx. From this triangle, this is we are triangle, sine theta will be opposite Fy over hypotenuse F. I know the value of F and I know the value of this angle. I can determine Fy. So if I cross multiply here, so Fy will be F sine theta. So it means that the horizontal component, the vertical component of that force, that is the contribution of this force that is acting like this, the contribution along y is Fy. So if I consider the same triangle, cosine of that angle theta will be adjacent Fx over hypotenuse F. So if I cross multiply, it means that Fx will be F cos theta. So Fx is the horizontal component of the force of F, and Fy is the vertical component of F. Okay, so that's the contribution of this force along y, and this is the contribution of this force along x. Okay. Now that's how you resolve it. There's a rule I'll give you that'll make it easy for you when you have like several forces acting together. If you want to get the contribution along the horizontal, what you want to do basically is to move this force. You want to move this force and place it on the x-axis. So if you want to move the force and place it on the x-axis, you move downwards like that. So if you move downwards, you are moving towards the direction in which the angle is given. This angle is inclined to the horizontal. So you press it down, and as you move, you are moving in the direction of the angle. So if you move towards the angle, you use cos. Towards the angle is cosine. And if you move away from the angle, it's sine. So that's a trick that you can use. Always remember that. So that will make it quick for you to resolve the forces. If you move away from the angle, that means if I want to place this force on the vertical axis, I have to move like that. So in that case, I'm moving away from the angle. So I'm going to use sine. That will be this force sine of the angle. If you are moving towards the angle, it's going to be this force cosine of the angle. Okay, so keeping that in mind, it will help us going forward. Okay, let's look at some examples. Example, the force of 8 Newton acts at 40 degrees to the horizontal. Determine the vertical and the horizontal components. And the horizontal components of the force. So how do we do this? So let's represent it in the diagram to make life easy. So you have the force. This is the Cartesian coordinate system. So you have the force acting like that to the horizontal. So let's assume it's acting in this direction. It's Newton. Okay, let me correct this. Let me put at not 40 degrees east. I think it's clearer that way. Not 40 degrees east. Let's put it that way so that I can represent it like this. Now, if I want to get the vertical component, this is y, this is x, this is north, and this is east. So it has to go that way. If it was north, west, it will go like that. So how do I get the horizontal components? That means I want to move this force towards the x-axis. So fx will be f cos theta. You remember the formula? So fx will be 8 cos 40 degrees, and fy will be f sine theta, and fy will be 8 sine 40 degrees. So fx will be 8 cos 40 degrees. That's 6.113 newtons. And fy will be 8 sine 40 degrees. It should be 5.14 newtons. So that means this force has been resolved into these two components. One that goes like that along y, which is 5.14, and the other one that goes like that, 6.13. So this force has been reduced into this. So which means if I want to get my original force back, what I need to do is just to find the resultant of those two forces. So if I do r squared equals 5.14 squared plus 6.13 squared, and you calculate the r, it should give you the 8 Newton force back. Okay, so that's the first example. Let's look at another example. Let's say you have a system of forces. This is the horizontal axis, and this is the vertical axis. You have a force that acts like that. You have another force that acts like that. So the question is, find the resultant. So if this is, let's say this is 30 degrees, and this is 10 newtons, and this is 8 newtons, and this is 20 degrees. This is y, this is x. The question is, find the resultant. So we are looking for both magnitude and direction of the resultant. See, example. So what do we do here? Now, this is a little bit different from the previous one, because in the previous example, we had just one force. So in this example, we have two forces. So what we need to do is that we need to find the summation of all the forces acting along x. So that will give you f of x. So f of x will be summation of all f of x, because we have f of x for this, we have f of x for this. Then the final f of y will be, so for each component, let's say for each force, fxi, let me put it that way. So where I is representing each force, and this will be summation over I of f of y I. Okay, so that means for each force, I will find the horizontal component and I'll sum them. But I have to keep in mind the direction. Remember, force is a vector. So which means if I resolve this, I have to keep in mind the direction in which the force is pointing. So if I resolve this along y, it's just like placing this force along this y, is going to point upwards. The arrow will point in this direction, this arrow. If I place it on the x, it's going to point in this direction. So which means for this, the component along y will be positive, and the component along x will also be positive because it's pointing towards the positive x. This is pointing towards the positive y. For this force, if I place this force on the y-axis, it's going to point towards the negative y. You can see downwards. So that means it's going to have a negative fx. So the component along y will be negative. And for this force, when you place it on this axis, it's going to point like this towards the negative x. So that means it's going to have a negative fx, a negative component along x. Hope that is clear enough. If you remember that rule, then life will be easy. So what do we do? For this one, if this is F1, let's say this is F1 and this is F2, it means that I will have Fx will be F1, which is, and this is, let's say this is theta 1. I just want to write the formula. This is theta 2, for example. So F1 cos theta 1, because it's going to be positive. And for this force, it's going to be negative, because if I place it along x, it's going to point towards the negative x. So it will be minus F2 sine theta 2. So why is this sign here? Remember, when you want to move this on the x-axis, you move towards the angle. So it's going to be cos. But if you want to place it here, you move away from the angle. So it's going to be sine. When you move away from the angle, it's sine. And when you move towards, it's cos. So don't memorize that, oh, x component is cos, y component is sine. No, depending on where the angle is placed. So if you want to memorize it like that, you have to make sure that the angle you have is to the horizontal. So that means you have to do 90 minus 20 and you use 70 here. But you don't have to do that. Just remember the rule that when you move towards the angle, it's cosine, and when you move away from the angle, it is sine. Okay. So which means fx will be, that's the resultant fx, the total fx that we have here will be 10 cos 30 degrees minus 8 sine 20 degrees. So that means fx will be, so that means I've resolved all the forces along x, because I have just two of them. So it will be 10 cos 30, which is 8.66, minus, so that's 8, then 8 sine 20, 2.73, 74 approximately. So 8.66 minus 2.74. So that gives 5.92. So Fx will be 5.92 Newton. So that's the summation of all the forces that act horizontally along the x-axis. Now let's find all the forces that act vertically. So Fy will be, so for this force, the y contribution of this force will be F1 sine 30, because when I move that force, I move away from the angle, like that. And for this, it's going to be F2 cos, so it's going to be minus F2 cos theta 2. So let me put the angle. Let me use the angle here. Sine theta 1. So this is negative because when you move it on the y-axis, sorry, this arrow will point towards the negative y. So that's why it's negative here. Okay. So Fy will be F1, that's 10 sine 30. And this will be 8 cos 20. So this will be 5, and this will be 8 cos 20. That should be 7.51. 51752. So this will be 5 minus 7.52 minus 2.52. So what that tells you is that the total forces acting along y has an overall direction that points towards the negative y. So that means now what I've done is to resolve all these forces into the components. So that means what I have now is Fx and Fy. But because the Fy point towards negative y, so if I want to represent that, it has to point downwards. So I have 2.52, and the x point towards is positive, so it has to point towards the positive x, like that, 5.92. So the resultant will point like that, as we planned previously. Okay, so if I put the direction there and I complete this triangle, so this should be 2.52, then I know that I can determine the resultant R. Okay, so let's use another page, 5.92, 2.5. Okay, I have 5.92 and I have 2.52. Then I have the resultant like that, and this is the angle, 2.52. Okay. So don't worry, don't mind me, I didn't draw the line to scale. So now the resultant R will be square root of 5.92. If I apply Pythagoras theorem there, 2.52 squared. So R will be square root of 5.92 squared plus 2.52 squared. Square root of 41.396839868. So R will be square root of that, 6.43. So that's the magnitude of the resultant. So what will be the direction? We need to find this angle. Tan of that angle will be opposite 2.52 over adjacent 5.92. So 2.52 divided by 5.92. So it's tan. So that means tan theta will be 0.4257. Theta will be tan inverse 0.4257. So theta will be 23 degrees. So the resultant will be 6.43 newtons at 23 degrees to the x-axis. Okay, because that's the horizontal of the x-axis. This is y, negative y, positive x. Okay, I hope that makes sense. I hope that is clear now. We'll stop there and I'll see you in the next video.